In this problem, we're going to write a system of equations to solve a scenario example here. And if you haven't already, pause the video to read this entire problem. One of the first things that we see is we don't know the amount of time that each individual was working on this project. So we will let some variables here, x, y, and z, represent the number of hours it takes each of those individuals, Beth, Bill, and Eddie, to complete one job. Now we need to re-express these variables in terms of the part of the job done in 1 hour for each individual. So if it takes Beth X hours to complete one job, the part of the job that she can complete in 1 hour is 1 over X. And similarly for Bill, 1 over Y, and for Eddie, 1 over Z. We end up with is that these individuals working together, 1 over X plus 1 over Y plus 1 over Z, are completing a job not in just 1 hour, but over 12 hours. And again, they complete one job in that amount of time. So this equation relates those variables together. Looking at the next statement, we're told that Bill and Eddie working together have painted a similar house or completed one job in 15 hours. So we can write a similar equation that it takes Bill, who was 1 over Y, plus Eddie, 1 over Z, over the course of 15 hours to complete one job. One day, all three worked on the same kind of house for 5 hours, after which Eddie left. Beth and Bill worked for another 10 hours. So Beth and Bill worked for a total of 15 hours, and Eddie only worked for 5 to complete the one job. So this one's going to be a little bit different. We can say that Beth and Bill, which is 1 over X and 1 over Y, worked for 15 hours, whereas Eddie only worked for 5 to complete the one job. I'm just going back up to make sure I haven't missed anything. So assuming no gain or loss in efficiency, how long would it take each person to complete such a job alone? So eventually we want to solve for X, Y, and Z. So now at this point we have 3 equations and 3 unknowns. And that was really the goal here, was to create 3 different equations relating the 3 different unknowns. It will take 3 if we have 3 unknowns. So after this point, it's just a lot of algebra to solve for these. And one of the things that we could do, since I'm looking at this and I see some similarities, like the 1 over X and things like that, I could take 2 equations at a time, and I would need to. I need to take 2 equations at a time and use either elimination or substitution method. Now, I will be honest, in a little while, you're going to learn some more advanced methods that may even work better than those 2, but I want to stick with what the problem's calling for, which is either substitution or elimination. So I'm looking at this first one and I'm thinking, if we divide both sides here by 12, and for the second equation by 15, we could rewrite those 2 equations as this equals 1 over 12, right? And this equals 1 over 15. And then multiplying the second equation by a -1 on each term. And then using that elimination process, we could get 1 over X equals 1/12 minus 1/15. All right, and that's that 1 over X is 1 over 60, so X must be 60. Okay, so that gives us one value here. I'm just going to place that over here just to Remember that one. Now, from here, I would need to select another pair of equations to combine and use either elimination or substitution. So looking through my equations, I could now substitute that x is 60 here. Let me circle this in different color right here. And then I could try to combine the second and the third equation. So I'm going to scroll down to get a little bit more space to do that here. So what I did here was I rewrote the second equation and I rewrote the third equation, but the only thing I did differently with that third equation was I substituted that x is 60. Okay, so at this point, again, just a lot of algebra. So I'm going to go through and here do this a little bit differently. I think I'm going to multiply through that 15. And then I'm going to multiply through the 15 and the 5 in the second one. Oops. Equals 1. Okay, so at this point, I see a common term that I'd only need to make one of them an opposite, thinking about that elimination method. So I'm going to choose to multiply through the first equation here by -1 on both sides. And that way, these two terms would cancel, or really become 0. So then I'm left with, and I guess I could go ahead and simplify that, because 15 over 60 would simplify to 1/4 minus 10 over z equals 0. And then keep solving here. And I could use cross multiplication to help me solve this. So z equals 40. And I'll make a note of that up above. Here in that z equals 40. Okay, so at that point, I have 2 of my unknowns, and I just need the third. So I'm going to go back to kind of some previous techniques where I would substitute in what I know into some of my unknowns, and I'm looking at the second equation because it's probably the simplest in that it only has 2 unknowns. I can now substitute in that z equals 40, and I can solve for the missing y. I think I'm going to go back, though, and use the form of this equation where I had divided both sides by 15. So again, scrolling down, let's see, and again, z is 40. So I'll have here that 1 over y plus 1 over 40 equals 1 over 15. And solving that, let's see, subtracting both sides by 1 over 40, I get that 1 over y equals 1 over 24. So that must mean that y equals 24. And I can come up here and make a note of that to finish answering my problem. So in overall, it would take Beth 60 hours to complete the job on her own. It would take Bill 24 hours to complete one job, and it would take Eddie 40 hours to complete that same job.